Good morning, everyone. Welcome to the first lecture of the course, Foundations of Immersive Technology. Before we move on to the course content, let us discuss the grading policy. Yeah, so this is the grading policy. Assignments 20%, minor one 20%, minor two 20%, and term project 40%. Assignments are individual. Term project is a group project. And so we started with these questions: what is AR VR? How to build AR VR applications? But before answering what is AR VR and how to build those applications, we first wanted to begin with something we already know. We know many examples of AR VR, so that's what we saw. So these are some examples, like how to place virtual furniture in our home to see whether it fits or not, or games like Pokemon Go, and like Lenskart, whether the specs fit neatly onto you or not. How do you look if you wear those specs? Online shopping, sometimes they give you an AR option, like Apple gives you an AR option to see how that device fits or looks in your real space. And AR measurement, without using a tape, just using your phone, you can measure things. And autonomous vehicles, Snapchat filters, Insta filters, and so on, right? Yeah. So now, what is AR? We know the examples, but from these examples, what do we see in common? Yeah, you were saying something. Virtual representation of something in real environment. Yes, sort of. Yeah. So basically, AR, as the name suggests, it is augmented reality, right? So AR is augmented reality. So why is the word augmented? No, augmented is not real. Augmented means what? In general, in English, augment means what? Augment means to add. Augment means to attach. Okay? So augmented reality means you have reality out there, you are adding something to it. Okay? So you are adding some virtual or digital content over the physical reality. Okay? So these are all examples of that. So if you actually see, like virtual furniture placement, you look at the room through your camera, and then you are augmenting a virtual furniture there. It can be a virtual sofa, chair, whatever it is, to see how it looks, right? Or in Pokemon Go, what are you doing? There is no real character in the physical world. That's a virtual character which you are seeing through your camera on some real space. Okay? And again, Lenskart, you are augmenting the virtual specs over your face. And again, online shopping AR option or AR measurement, you are augmenting the numbers, the distance, the length over the actual physical distance which you are seeing through the camera, right? And autonomous vehicles, it's not just AR, it's many more things. We will see some of those things. Snapchat filters, this is a prime example. All that you're doing is you're augmenting something over your face, right? It can be mustache, it can be horns or something like that. So you're just adding in addition on top of something already existing. This thing which you are adding is virtual, that which is existing is real. Okay? So there is physical reality and you are adding some virtual content or digital content. Okay? So one simple way to explain this is to add digital content, digital or virtual, over physical content. Okay? So let's look at let's look at the definition and some examples which we discussed. Some more examples we'll see. So augmented reality is a technology that overlays digital content onto the real world, enhancing the user's perception and interaction with their environment. Okay? The entire thing is visible, right? Yeah. Yeah, so let's look at some examples. Pokemon Go is one very good example which you already know, right? And then Snapchat filters, as you already know. And IKEA app has this feature that you can place virtual furniture and you can decide how it looks even before buying it. This is a very useful feature, right, to make important decisions. Measurement, which you said. So we have an object here and we are overlaying the measurement in digital form over the physical object, right? And head-up display, this is also an example of AR. You just have a glass, you are overlaying some digital content over that so that you need not move your head to see that information. And your vision is also not really obstructed. You can just see through and you can look at the information whenever necessary, right? So indoor navigation is one other example of AR. So let me play a video to show how indoor navigation helps. Sorry. Yeah, so let me just start again. So imagine you are in a supermarket, you don't know where to find the item, right? Because each supermarket is different and usually we face this, where to find the item, how to search for the item. There is no internal search, right? So if it can show the path to that item, that will be very useful, right? And any other examples you can think of, many other places this is useful, indoor navigation. University, like in our campus, new students may not know, even old students may not know where everything is there, right? Where is library or where is a particular faculty's office, which happens quite frequently. And where is this particular department, where is that particular lab. All these things are regular scenarios which we face. So having such an app for any big campus, it can be university, it can be a mall. Within a mall, you don't know where a particular store is, right? You keep searching for that. You don't know which floor it is in, and even in that floor, you don't know in which at which point that store is located. Or in airports, where is the terminal, or where is the security check-in, or where is the particular airways check-in. All these things. So this is a very, very useful thing for multiple scenarios, right? And AR is actually very helpful. This also has a lot of commercial viability. If you can build an app which does indoor navigation, it's like it will be as useful or even or as useful as Google Maps, right? The way we are using Google Maps day in and day out, this will also be very useful for a particular place. So so this is a very good example of AR application, right? And all right, now more applications like education. Can you think of some education applications based on AR?
Lab experiments, like
Okay.
any chemistry experiments which involve hazardous materials,
Mm.
which can be done in AR.
How in AR?
Like everything
Simulating.
is simulated, and if anything goes wrong, also the lab will not get spoiled, or the person will not get
Right, but is that AR?
Yes.
How is it AR? What is the physical reality? What are you augmenting there?
In a lab environment, we are augmenting chemicals and all the necessary equipment.
Augmenting on what?
Like if
So you're saying lab environment means I just have table and shelves and the chemicals mixing with each other is being augmented.
Yes.
But what is
But we can use we can use gloves. With gloves we can add chemicals or something.
gloves? Real gloves?
Not real gloves, but the gloves which can interact with the air.
Okay, but is that AR or something else? I mean, is it pure AR?
Not completely.
See, AR means a simple example of AR in the in the case of chemistry lab is, say you have the all different kinds of chemicals in the bottles. When you look at them through your phone, it will name them, it will label them. Okay, this is this chemical, this is this chemical. So you are just looking at them through your phone, and it is telling you what bottle is what chemical. Okay, and say if someone is actually mixing, and say you get a new chemical. Now again, when you point your phone, it will tell you what is that new chemical. Or when you are doing this entire process of lab experiment, it may give you a live commentary on your screen. Okay, he's mixing this, mixing that, this is the output. He's mixing so many ml of this chemical with so many ml of this chemical, and you got this new chemical. So live commentary is coming on the screen, like in the form of text or audio or whatever. So basically whatever is happening physically. You are overlaying some digital information in the form of text or audio. Or let's assume you go to a monument. When you point your camera at that monument, it will give you all the details of that monument. What is its name, what is its history, who built that, when was it built, what material was used, all these things. So basically a wiki page is sort of overlaid on that monument, or summary of wiki page, or important information, right? What you said, it is, we will come to that. It is not exactly AR, it is mixed reality. So we will come to that. But pure AR is, you just need mobile phone for that. Simple basic device, you just, a mobile phone is enough to build AR applications. Okay? And object recognition, this is something which you would have seen already, like Google Lens. When you point at an object, it tells you what that object name is, or it gives you images of that object, or information about that kind of objects, right? But there what we are doing is, we are taking an image of that object and we are doing image search. All right. Now once we do the image search, whatever information we get, if we can summarize that information and overlay it there itself in the camera view, that is AR. So I am looking at an object, I am not being taken to a different screen, a web page or something. The camera view remains as it is. I am still looking at the object through my camera, and the digital content is generated and overlaid on my camera screen. That is AR. Okay. And again, museum objects, when you go to museum, there will be so much of information, but you have no clue of what you are looking at, right? There may be some small plaque which gives you some description, but still there can be much more information which can be revealed, which cannot fit in a physical plaque. So if you point your phone at a museum piece, it can be a painting, it can be a 3D object or whatever it is, that information is overlaid on your camera screen, on your phone screen, right? So that is another use case of AR. And recreating or reenacting some monument or event from the past at a given site, right? Say if you go to some war site, right now, I mean, war happened long back, but right now you may see some incomplete monuments or some broken monuments or something like that. Say, when you point your screen there, maybe something is recreated. If someone recreated of how it was broken or how the war had happened, that may come on your screen, that can be overlaid on your screen to get an idea of, okay, what happened at this site, right? So recreation or reenactment of something from the past, right? So that is also an example of AR. And say scanning a clothing items barcode and it showing us the pictures of some celebrity. Okay, I didn't change the screen. Sorry. Yeah. So these are the things which we discussed. Education. Another example of education is, say, I mean, in school textbooks we have images, right? Suppose I just have an image of solar system, but that is not enough for a kid to visualize solar system, right? If only I can overlay a 3D model of solar system on that page where solar system is being discussed, that will be very useful for the student, right? Or any physics experiment. Say if there is an experiment of electric circuits, how the current is flowing, when the gates are open, gates are closed, when is it flowing, when is it not flowing, when is it in a sequential circuit, how does the current flow, in a parallel circuit, how does the current flow. So images will take you only to a certain point, but simulation, a 3D simulation will make it look very real, right? So this simulation is built elsewhere. All you are doing is you are sort of overlaying that 3D simulation on this textbook page. So when you are seeing a particular image or some particular text which is describing a physics experiment, you can overlay this 3D simulation and then immediately one can visualize what is happening there, right? So that is another very useful example of education, right? And object recognition, I said, like Google Lens and looking at museum object and then reenacting some monument, that also I said. And then scanning a clothing item's barcode and it showing us the pictures of some celebrities or models wearing it to give us an idea of how it looks when one wears them. So you go for shopping. Now you see different kinds of clothes, but just by looking at them, you don't understand how it looks. One option is you actually try it yourself. Another option is just to see how it looks when someone wears them, right? So you scan the barcode and the image should pop up. Already images are already there, like on e-commerce websites. At least if those images can pop up when you are looking at this particular apparel offline, that will be helpful. Or another option is you don't really try it physically, but you try it virtually. Yes, yeah, smart mirrors in shopping malls. So I have a dress which I want to see how it looks on me, right? So it should, once I scan that dress, it should sort of show me how it looks on me, right? But here again, it's a very complex thing because if you take that measurements as it is onto you, it will look very artificial, right? It should give you an estimate of how does it fit your body shape, right? Not any ideal body shape. It may be slightly loose to me, it may be slightly fit to me, and it may be loose at some points, fit at some points. So it should understand my body structure and tell me or make me visualize how it fits onto my body structure, to my complexion, to my body measurements, all these things. Okay, so that is another very useful thing. All right, so these are many, there are many more applications of AR. You can think of many more. There is no limit. So wherever you can enhance the physical world with some digital content, that is an example of AR. To make your job easier, like this last option reduces your task a lot by, you can save a lot of time rather than physically trying out different outfits. You can actually see virtually how they look on you and then make a decision, right? Wasting time or there is always a limitation to try out physically, right? And again, education, like we discussed, it is very useful for kids to visualize how it is going to look, right? Watching a video is different. So you see, there are different levels in which we can augment some real content. One is, suppose if I see an image in my textbook, I can just give a YouTube link there so that immediately a student can click that link and watch a YouTube video of, say, how a solar system looks or how an electric circuit works. In this case, you're not really creating any 3D simulation. You're just overlaying some YouTube link. Okay. Another option is you're not overlaying the link per se. You are extracting that video and overlaying that video there on the image. right? That is another example. So now he need not move away from the textbook page. He can stay on the textbook page and watch the video right there. Another option is you create some 3D simulation and overlay that 3D simulation there. It's not a video, it's a 3D simulation. Like he said, chemistry, chemical experiment simulation. You perform or you build a 3D simulation of solar system or electric circuit and overlay that there. The next advanced step is you make that simulation interactive. So what do we mean by interactive?
We can interact with objects.
Like how? Okay.
By hand gestures or something.
Yeah, we can move the virtual objects, or some more specific way of saying it is, suppose I have electric circuit. Now that 3D simulation is built with some particular parameters, some specific voltage, specific resistance, specific current, all those things. Suppose I want to see how it behaves if I change any of these parameters. So I can change those and the 3D simulation updates. Or imagine if it is a collision, or if it is a pulley system, or if it is a lever experiment, or any physics experiment. I want to change the parameter, say a falling object, gravity. Suppose I want to see how fast an object falls on the surface of moon. So gravity will differ. So I will change the gravity constant, and the simulation should change. Right? So you are interacting with it. You are changing the parameters and then seeing how the experiment updates. Or you can even move the objects if necessary. So this is like the final ultimate stage. This is like virtual lab. Right? Normally in lab, what do? We perform experiments, right? If I give these values, what will be the output? Now same things we are doing completely virtually. I change the values in the 3D simulation and it gets updated automatically. But that is a more complex thing. One step below is you just fix some values and show the 3D simulation. So I'll just get some idea. Okay, this is how it's going to look. I can't change the values, but at least I'll get an idea. Okay, but the more complex and the ideal situation is you should be able to play with it. Okay, so this will be helpful particularly, because not all schools and all colleges have high-end equipment or all lab facilities. But at least if you provide this kind of virtual lab facilities, that will be very helpful for students to learn, right? So these are all multiple areas in which AR can be helpful. Number of areas, there is no limit on where it is useful, right? Can you think of some more examples than what we discussed? Not just the examples which you know. Some of the examples which you mentioned were the examples which you know already. Some other examples which you don't find applications already, but which can be built, like this indoor navigation thing. You don't have any app right now to use.
Interactive holograms.
Interactive holography. Yeah, holograms. So that is again like mixed reality. Yes, you see, mixed reality is like an advanced augmented reality. We will come to that. Yes, like Iron Man, Jarvis, you sort of project a hologram and you play with it, right? Yes, that is an example. What else? Yeah, don't limit to AR. Whatever examples come to your mind, you tell that. I will tell you whether it's AR or VR or mixed reality or whatever. So let's assume we have this, interactive hologram. Now, what are the use cases? Where do you use it?
While designing any vehicle or something, you can.
Right. Yes. Yeah, that's a very good example. You can play with the vehicle, you can play with the parts, remove them, add the parts, or change the shape of the vehicle, or many things. Another very good use case is in industry, right? When you are dealing with machinery, or say when you want to learn something about a machine, this can be helpful in teaching someone how that machine works, right? You can play with that machine virtually and then say, okay, this part is this part is that, this part does this part does that, and if you remove this will happen, all kinds of things. Or something as simple as say we have printers in our institute. All those are large printers. They have many functionalities, and many times we don't know how to operate that printer, which button to press, or where to put the paper, or what happens if the paper is over, or what happens if some paper gets stuck, or what happens if the printer gets repaired, right? So which part to open, which part to put back, in which order to put, all these things, it is difficult. Either you physically be present there, or it is you just make a video of it, or the best thing is you try to make this training interactive. Suppose I point my camera at the printer and it tells me, okay, this part is this part is the paper tray, this part is where the ink goes, this part is where the scanning is done. So these different parts are displayed on the screen. And also, suppose I can select an option, I want to print a paper or scan a paper, or add ink, or change the what do we say, cartridge. These things, if once we select that option, then it should give me steps. Okay, open this part and take the cartridge out, and then put a new cartridge, and then close the lid, right? So it should at least point, it should recognize the parts and then guide me step by step what to do next, right? So here multiple things are happening. One is part recognition. You should be able to recognize what you're looking at. And second is you overlay some digital content on individual parts. Okay, so can you tell me what technology is used for the first and what technology is used for the second? Very broad technology, broad science.
Object detection machine learning, like YOLO.
Yes, that is still specific. So what I was expecting is so we have two things. Yes, object recognition and all that, but still the fundamental science behind object recognition is computer vision. Okay, so computer vision means what? You are looking at whatever, your camera is looking at some input, some visual information. You are decoding it, you are analyzing it, and you are recognizing the things in your vision. Human vision does it very easily. I can actually differentiate people, chairs, tables, laptop, mic, all these things. But what are we doing? We are sort of breaking down the entire visual information which is given to us into objects, right? And many things, what actions people are performing. So we can do object recognition, face recognition, action recognition, pose recognition. All these are all part of computer vision. So computer vision is basically related to analysis or breaking down whatever information is given to you. What is the reverse? Suppose I want to build a particular visual scene. What should I use? What do I use? Not any specific tool, but the most generic, like computer vision, what is the counterpart? So we basically use computer graphics. So whatever you know, whatever you see, in all the examples that we discussed so far, whatever information is overlaid, be it Snapchat filters or furniture or education or all the things that we discussed so far, you are overlaying some digital content. Now, where does this digital content come from? Either there is an image of it, that's a different thing. You just overlay an image on top of your phone screen. But most of the times, it is not just an image. You need to generate that content, that digital content. It can be text, it can be image, it can be 3D information, usually like IKEA furniture. That's a virtual furniture. That's a 3D content. Or suppose the 3D simulation. Again, that's a 3D content. Education, which you overlay some 3D simulation, that's a 3D content. Or you can, so what examples? Yeah, recreating or reenacting some event or monument. Again, that's a 3D content. So all these need to be generated or need to be built. They don't exist in the reality. Or like Pokemon, something as simple as Pokemon character that needs to be built. It's not there out in reality where you can take a picture and then overlay that picture of Pokemon. No, you have to build that character, right? So all these are generated using computer graphics. Anything you generate, anything you build from scratch, any visual thing you build from scratch is built using computer graphics. Okay, it can be 2D graphics, it can be 3D graphics. It doesn't matter. It is graphics. So computer graphics is synthesis. That is building up. So these are the two opposite ends. You are already given some visual information, you break it down, you analyze it, you detect various things, you detect actions, you detect objects, all these things. You basically try to understand the scene that is given to you, the real physical scene that is given to you. So that is computer vision. Okay? The other end is you try to create an entirely virtual scene, virtual object, virtual scene, virtual image, whatever it is, you create it from scratch. That is computer graphics. Okay? So AR, VR does not need computer vision, but AR, wherever AR is involved, both are necessary. Because in AR, what are we doing? We are detecting something and we are overlaying something. So whatever it is, we are detecting either some specific experiment from a textbook page, or we are detecting a particular object in our camera, or we are detecting a particular museum object, or we are detecting a particular monument or some space, whatever it is. We need to first detect, we need to first recognize what we are looking at. So computer vision is necessary. Your camera input should be analyzed. So you need to use computer vision algorithms. Whatever those algorithms are, like YOLO is one, those frameworks, all these are different computer vision frameworks. They allow you to do face recognition, object recognition, or action recognition, all these things. Those are all based on computer vision. Okay? Once you do that, now you generate some virtual content. It can be 2D content, 3D content, or plain text, whatever it is. You generate that and overlay it on your phone screen. Okay? So that requires computer graphics. Alright? So both things need to be used. Input and output. Input requires computer vision, output requires computer graphics. Okay? So that is what AR does. Alright? So let's stop here for today. We'll continue tomorrow. Any doubts so far? Clear? Whatever we discussed today is clear, right? Simple. AR, simple. You overlay some digital content on some real content. As simple as that. Augmented. You add some digital content. Augment. That is AR. Okay? So we will continue tomorrow. So